This is the Spicy 100, question 26.
Welcome back. So the recommended time for this one is 6 minutes, and you can definitely use a calculator. You'll be in a spot bother without a calculator. So I will read it to you. A solid iron wrecking ball used in the destruction of buildings is modelled as a sphere with radius 0.5 meters, measured to the nearest centimeter. The mass of the ball is 3.7 metric tons, measured to the nearest 5 kilograms. Find the density of the ball in kilograms per meter cubed, giving your answer to an appropriate degree of accuracy. So there's quite a lot of information there, so have a good read. So you've got 6 minutes, set a timer, pause the video, and best of luck with 26. So we've got a few things to contend with here. So we've got a mixture of units, that's one thing, and we've got some formulae, so we need to know the formula for density. We've got a sphere as well, so we're also going to need to think about what the volume for the volume of that is. But let's first of all start with our unit. So it says it's 0.5 meters is the radius to the nearest centimeter. So let's consider our R, our radius. So first of all, 0.5 meters, let's consider that's 50 centimeters. Now, because it's to the nearest centimeter, that must mean then that our R is between 50.5 and 49.5 centimeters. If we then convert that into meters, so that means that the radius is going to be between 0.505 meters and 0.495 meters. So the upper bound in terms of the radius will be this one, and our lower bound will be here. So we've converted to centimeters and then back to meters, partly because the question is asking for our density in the end in kilograms per meters cubed. So I'm going to want to be dealing with meters. Let's consider the mass of the ball. So 3.7 metric tons. So we need to know that a metric ton is 1,000 kilograms. So 3.7 tons is going to be equal to 3,700 kilograms. So the mass of the ball is measured to the nearest 5 kilograms. So if we divide that by 2, get 2.5 above and below. So the mass is going to be between 3,700 and 2.5 kilograms. We'll take it off. 3,697.5. Use a calculator if you're not confident there. So we've now got the upper bound and lower bound for our radius and for our mass of our wrecking ball. So we're calculating density, so let's remind ourselves. So the formula for density is equal to the mass of an object divided by the volume. So at the moment we don't have the volume, we've got the radius and we know it's a sphere. So what we need to remember is the volume of a sphere is 4/3 pi r cubed. So what we can now do is we can find the upper bound and lower bound of the volume of our sphere using these that we found earlier. So if we look at the volume of our sphere, the lower bound is going to be 4/3 pi multiplied by 0.495 cubed. And that's going to give us 0.50805 meters cubed. Now if we look at the upper bound, so that's going to be the same formula, 4/3 pi, and then it's going to be 0.505 cubed, and we're going to get 0.53946 meters cubed. So we have the upper and lower bounds for our mass now and for our volume. So we can use that then to find the upper and lower bounds for our density. So let's remind ourselves. So the formula for the density is mass divided by volume. So if we were trying to find the upper bound or the lower bound, so if we're trying to find the lower bound for our density, what we would need is we would need the largest v, because we're dividing by that, and the smallest m. So if you want to make a fraction small, you make the numerator small and the denominator big. So we're going to take the lower bound for the mass, which is 3697.5. And we're going to divide that by the upper bound for the volume, which is 0.53946. 946. And that's going to give us 6854.076. 6299. So we're not going to need all those decimal places, but just double check you get that too. And then the upper bound is going to be the upper bound for the numerator for our mass. So that's 3702.5. And divided by the lower bound for our denominator. So you want to make your denominator as small as possible. So that will be 0.50805. And we put that in a calculator and we get 7287.669. So using these answers for our upper and lower bounds for the density, we need to give our answer to an appropriate degree of accuracy. So it's basically to what degree of accuracy, how many significant figures will they both round to the same thing? So for example, for two significant figures, the lower bound would be round to 6,900 and the upper bound would round to 7,300. So they're not the same to two significant figures. And actually, the best we can do is one significant figure. They both round to 7,000. So our density is going to be 7,000, and the unit for density is kilograms per meters cubed. And that's the appropriate degree of accuracy because that's what they both would round to. So if you're up for continuing the challenge, why don't you move on and have a go at 27? And if you're enjoying the Spicy 100 series, please do subscribe to the Hench Maths channel.